So this is method 1. The method 2. Is this the xt will be equal to the homogeneous solutions plus the particular solutions, okay? And earlier we have done is we have found the particular solutions equal to f now divided by k, right? And that is the content we learned in chapter 3. And the homogeneous solutions, basically, the homogeneous solution is the solutions of x m x double dot plus c x dot plus kx equal to 0, and for okay, so that is the corresponding, we call the homogeneous solutions for this one. So basically here x of t, if you remember, that is zeta omega nt and a times cosine omega dt plus b sine omega dt. Because for this one we have the characteristic root minus zeta omega n plus minus j times omega d, right? So this is from our chapter 2. If you remember, this is our real part, and real part define the profile, the Cheng profile, and that is come to here. That is our real part, right? And the imaginary part, omega d, basically equal to omega n times 1 minus zeta squared. This one gives us how frequent this oscillating. So that is given by here. So that is the information we learned from the beginning of this class. Okay, so now everything together, we simply, if you like, we can replace this one as a total. Then we substitute the soft AB by imposing x total solutions to initial conditions. And the total velocity also equal to 0. Okay, so basically here, let me put into this with the initial conditions x0 equal to 0 and x dot 0 equal to 0. So with such an additional requirement I imposing here, then you solve for A and B and do a little bit more arrangement, you will find that is exactly equal to this one. In the handout today, if you turn to the next page, the second method, that is to complement the second method. Okay? So here I want to show you, if you do the things, think through, and do the things correctly, then you should get the result, the same result. You okay? So this one is in particular for this 0 initial conditions. And another example I can share with you is this. On the other side, and listen this carefully, okay? On the other side, if we have a different example, say I give you the different initial conditions. So for another example, if the both are not 0, you simply repeat the calculations by substituting such a different initial conditions. You can still solve for A and B, right? Okay, and that solution definitely will be different from here. So again, the convolutional integral, I want to make a comment, that is corresponding to a very particular initial condition, that is 0 conditions. Keep this in mind. You good? Okay. The third method. Okay, right now I want to representing is the third method using the Laplace transform. And let me do the things here and detail we refer to them. Okay, transform. So for this case, we with the initial conditions both equal to zeros. So from here we can obtain is this follow up and x that problems described like this. Okay. And then we take the Laplace transform on this side and with initial conditions, so that is become this capital X squared and plus 2 zeta omega. Okay, so that is an individual Laplace transform on the derivative, first derivative, etc. So we don't consider, say, the initial conditions equal to 0. So that means that becomes the s squared plus 2 zeta omega ns plus omega n squared and times capital and equal to the Laplace transform of this one, f now divided by n equal to f now divided by n times s. Okay? So that one is f now m times 1 over s. So therefore here we do the little bit arrangement. So here is a function of s basically equal to this f now divided by n and then s squared plus 2 zeta omega n s plus omega n squared 1. So that is come to this expression here. Okay. And so basically we have the expression basically like this. Okay. And starting from here, and those things are available from your handouts. And either you can look into the tables, Laplace transform table, and for the test purpose, for the testing purpose, this kind of complicated one, I would definitely provide you the tables. Okay. But for your exercise, you better to know why it's going on here. And let me do this. If we say refer to the Laplace transform tables, then you can quickly know the result will be like this. Okay. And if you say wondering why, and that's the detail, let me skip the details. Okay. This is the result. You can see this result is the same as the first approach and the second approach. Okay. So again, using the Laplace transform, the Laplace transform is such a case, it allows us to deal with the initial conditions that is approaching to equal to 0. So here for all the among the three approaches being presented, they basically provide us the same result, but those results are in particular that is for the total solutions. Total solutions corresponding to 0 initial conditions. Keep these things in mind. Okay? You good? Okay. So that is a very typical, thorough expressions, and with a very simple force And here, up to now, we've been demonstrated is the total response of the systems to such a simple force constant. Are you able to give yourself a try if we have a different force, like, say, this? So for this one, simply is this, that becomes T here. Right. So are you able to try the different approach, like the convolutional integral, Laplace transform, or using the approach from chapter 2 or 3 combined together? No, I don't think so. The chapter 2, 3 are for particular periodic function, but not for this one. Okay, so give a try. At least you have 2 approaches available: convolutional integral, Laplace transform. And the Laplace transform, you can see from compared to the handouts, that needs a lot of the work. So I would suggest you, my personal preference is Laplace transform is quicker. Okay, it's much quicker and then less work in calculations, and that's my preference. But really up to you. At least you know that the multiple methods are available to you. Okay. So remaining, coming back Friday, I will go over, if you have these handouts print over with you, or otherwise you print out the homework 11. So the first part of homework 11 will have everything here. I'm going to go over the 3 more examples in detail on Friday. And then homework 11, there's a 6 problems, and only 5 available for your calculation solutions. Look at the last problem, the problem 6, and that I provided with the solution, and that is very the most rigorous. So I dare not to ask you to do it. I do it with the solution. So maybe you can print out that one, bring over with you. Then I will try to finish all the examples on Friday. Okay. Okay. Thank you.